Hi all. Today we are going to learn about the network models used in computer networks. In this session we will learn about ISO OSI reference model and the various layers of OSI model. First let's understand what is an internet. When two or more networks are connected together, it is called as internetwork or internet. The first internet network was ARPANET, which is introduced in late 1960s. The protocol used in ARPANET is Network Control Protocol, which is abbreviated as NCP. Later, they have introduced some new protocols called Transmission Control Protocol and Internet Protocol, TCP/IP. A protocol defines what is communicated, how it is communicated, and when it is communicated. It is simply a set of rules. The key elements of a protocol are syntax, semantics, and timing. Syntax are the predefined set of rules and semantics defines the meaning for each of these rules. Timing represents the time at which these messages are to be sent. Next, let's see what is a network model. Computer network models are responsible for establishing a connection among the sender and the receiver for transmitting the data in an easier manner. The various standard network models used are ISO, OSI, and TCP/IP. Both these models follows layered architecture. In layered architecture, the entire system is divided into various layers. Each layer has a well-defined functionality. Let's understand what is the need of network models in internet network. Consider two computers are communicating with each other. The first computer is a system which uses Mac OS and the receiver system is a computer which uses Windows OS. So if we send a message from Mac OS to Windows OS, there need to be some sort of conversions required so that it will be received properly in the other end, because these two operating system uses different rules, different protocols and different strategies for encoding and decoding a message. So in order to perform a successful transmission of data, we have to introduce a common protocol or a common guidelines to send a message from the sender to the receiver. For that purpose, we are using network models. The first model is ISO OSI model. In 1970s, International Standard Organization proposed a network standardization called Open System Interconnection. It allows two systems with different architectures to communicate each other. OSI model is used as a reference architecture and it follows layered architecture style. That is, the entire system is divided into 7 layers with each layer having an individual, unique, well-defined functionality. The layers are named as follows: application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. This physical layer, data link layer, and network layer are called as hardware layers of OSI model. Transport layer is considered as the heart of OSI model, and the other 3 upper layers, that is session layer, presentation layer, and application layer, are considered as the software layers of OSI model. In the center side, the data will flow from up to downwards. That is, first it will move from application layer to presentation layer, then to session layer, then to transport layer, network layer, data link layer, physical layer, etc. In the receiver side, it will go upwards. That is, through physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Let's understand the functionality of each layers in detail. The first layer is the physical layer, which is considered as the lowest layer of OSI model. The main functionality of the physical layer is to transmit the individual bit from one node to another node. Physical node establishes, maintains, and deactivates the physical connection between the devices. It specifies the mechanical, electrical, and procedural network interface specifications. The main functions of physical layer are line configuration. That is, it defines the way how two or more devices can be connected physically. Physical connection means we are used to connect two devices using wired connection or even through wireless connection. In wired connection, we may use telephone lines or optical fiber cable to connect two devices to the network. Next is data transmission. It defines the transmission mode to be carried out during the communication, like whether we have to use simplex, half duplex, or full duplex mode between the two devices on the network. And the next is the topology. We have learned different types of topology like bus topology, ring topology, star topology, tree topology, etc. So the physical layer defines the way how network devices are to be arranged physically in real time. Next, it will define the type of signal to be used for transmitting the information. So these are the key functions of physical layer. Next is data link layer. So after establishing the physical connection between the two devices, there is a layer which is responsible for error-free transfer of data frames. Frames are simply the collection of raw bit streams. Data link layer defines the format of the data on the network. It is the main reason for reliable and efficient communication between two or more devices. This layer is also responsible for the unique identification of each device that resides on a local network. As we all know that every system should have a unique ID. Through that ID we can send a particular message from the sender side to the receiver side. So data link layer is responsible for this unique identification of every device in a local network, that is LAN. Next is the functions of data link layer. The first function is framing. Data link layer translates the physical raw bit stream, that is the collection of all the binary digits or the data from the sender to the receiver, into packets known as frames. So frames or packets are simply the collection of raw bit streams. The data link layer adds a header to the frame that contains a destination address. Based on this destination address, the frame is transmitted to the corresponding receiver. Next is flow control. Flow control is a technique which ensures constant data rate is maintained on both the sender side and the receiver side. Consider the scenario if the server computer is having a higher data transferring speed and the receiving side having a lower data transferring speed, then it is not possible to receive the packets as per the speed sent by the sender. So in order to perform successful transmission, we have to control the flow of data through the network. So this flow control is done by the data link layer. Next is error control, which is achieved by adding a calculated value called CRC, cyclic redundancy check code. We will learn about this CRC code in the second module in detail. So it is just a code for identifying whether the message is received correctly in the other end. If it is not received correctly, the receiver will send an acknowledgement for the retransmission of the corrupted frames. So these all are the functions of data link layer. Next is network layer, which manages the device addressing. That means it is used for identifying each devices in the network and tracking the location of devices on the network. For that purpose, we are using some protocols called network layer protocols, that is IPv4 and IPv6, and it will also perform routing and forwarding the packet from the source to the destination. Let's see the functions of network layer in detail. The first one is internetworking, and internetworking is the main responsibility of the network layer. It provides a logical connection between different devices that is used in a particular network. The next one is addressing. A network layer adds the source and destination address to the header of the frame. This addressing is used to identify the device on the internet. So if we are sending a packet from the sender to the receiver, we have to find out the destination or the target device. In order to identify that particular device, this addressing is used. The next one is routing. As the name suggests, it is used for routing the packet from the source to the destination. There are different paths from the source to the destination. So the network layer will execute some routing protocols or algorithms to find the best optimal path out of the multiple paths from the source to the destination. The last one is packetizing. The data from the transport layer is received as some large size of data. This large size of data are divided into small packets. This process is called as packetizing, and these packets are routed from the source to the destination. It is achieved by Internet Protocol IP. Next is transport layer, which is considered as the heart of OSI layer. Transport layer ensures that messages are transmitted in the order in which they are sent and there is no duplication of data. The main responsibility of the transport layer is to transfer the data completely from the source to the destination. It receives the data from the session layer and converts them into smaller units known as segments, and these segments are transmitted to the network layer. The network layer will again perform packetization. Two protocols are used in this layer called TCP and UDP. TCP means Transmission Control Protocol and UDP means User Datagram Protocol. We will learn about TCP and UDP protocols in detail in module 5. The next is functions of transport layer. The first one is segmentation and reassembly. When the transport layer receives the message from the session layer, it divides the message into multiple segments, and each segment is assigned with a sequence number that uniquely identifies that particular segment. When this message has arrived at the destination or at the receiver side, then the transport layer at the receiver side reassembles the message based on their sequence numbers. So the sequence numbers are used to segment and reassemble at the server side and at the client side. The next is connection control. The transport layer provides two types of services: connection oriented service and connectionless service. A connectionless service treats each segment as an individual packet, and they all travel different routes to reach the destination. While as in a connection oriented service makes a connection with the transport layer at the destination machine before delivering the packets. In connection oriented service, all the packets travel through a single route. The last one is flow control. The sender side and the receiver side may have of different data transmission speeds. In order to control this transmission flow, we are using flow control in the transport layer. The next one is the session layer, which is used to establish, maintain and synchronize the interaction between the communicating devices. The main functions are dialogue control and synchronization. Dialogue control means creating a dialogue between two processes, or we can simply say that it allows the communication between the two processes, which can be either through half duplex or full duplex. Session layer adds some checkpoints when transmitting the data in a sequence. If some error occurs in the middle of the transmission of data, then the transmission will take place again from that particular checkpoint. This process is known as synchronization and recovery. So synchronization and recovery is used for ensuring the successful transmission. The next one is the presentation layer. Presentation layer is mainly concerned with the syntax and semantics of the information exchanged between two computers or two systems. The main functions of presentation layer are translation. The messages sent by the user may be of different data formats, like it may be a text data, it may be an image, it may be a video file or an audio file. So in order to translate them into a common machine dependent form, we have to do some sort of encoding. This process is called as translation. In order to ensure the security and privacy of the data being transmitted, we have to perform encryption or decryption while transmitting a message. Encryption is a process of converting the sender transmitted information into another form and sends the resulting message over the network. That means decoding the message into some ununderstandable form so that only the receiver can retract the data into its original form. So this is used for preserving our data from unauthorized access and thereby ensuring the privacy of our data. The third feature is compression. Data compression is a process of compressing the data, that is, it reduces the number of bits being transmitted over the network. Data compression is very important in multimedia transmission, such as transmitting a text, audio or video file. And the topmost layer is the application layer, which serves as a window for users and application processors to access network service. It handles issues such as network transparency, resource allocation, etc. This layer provides the network services to the end users. Don't ever think that the network applications like Mozilla Firefox, Google or Skype is the functions performed by application layer. Definitely it is not like that. Application layer is simply a set of protocol which is used to execute these email, Skype, WhatsApp or any other network based applications. The main application layer functions include file transfer, access and management (FTAM). An application layer allows a user to access the files in a remote computer or to retrieve the file from a computer and to manage the files in a remote computer. And it will also provide mail services, that is, an application layer provides a facility for email forwarding and storage. So these all are the various layers of the typical ISO OSI model. Thank you.